Okay, before we start day 3, I want you to fill this out here. Just review what you've done. Review through this and see if this is anywhere near what you were thinking. And what I want you to do also, maybe I should explain this even in more detail. What would the degree be? Somebody else do one together. So the degree of this, so x times x times x. Even though there's a whole bunch of other stuff, it would be x to the third power. Okay. What is the end behavior? Well, you'd only know that if you type into a calculator. So I want you to type in your calculator. So put in the calculator, hit graph, and just real quickly here, what's the end behavior? Well, the end behavior means what's going on the ends. So if I went to the end of the graph to the right and to the left, what's going on? Well, if I'm going to the left, this graph is going down. So I'll just put down for now. We'll just describe it like this. So put how it's going to the left and how it's going to the right. So left, right. Now going to the right, it's going up. So it's a down-up, a down-up situation. Letter C, what are the roots? So if you look at this real quick, we'd also look over here. So it should be a -4, and it does cross at -4. It should be a -1, it does cross at -1, and it should be a 3. So -4, -1, -3. And then how many directions are on this polynomial? Well, it has this shape right here. So it has 1 direction, 2 directions, 3 directions. Okay. So I want to pause, and I want you to finish this. I want you to finish it out, do the other 3, and we're going to look for a pattern to help us because this is going to be a really easy day if you see the pattern. So try it out. Try 2, 3, and 4 the same way we just did here, number 1. Okay, so hopefully you got a chance to do these. So on this one, if we multiply these together, there'd be 4 x's being multiplied together, so it's x to the 4th. When you put it in the graph, it looks something like this. Again, this is a general sketch, kind of a W shape, up and up. The zeros that are coming from here. And then how many directions did it have? 1, 2, 3, 4. Now, these two down here, look at these guys, and they're almost exactly the same thing. This has a negative, this doesn't. 5, x to the 5th power 5. Oh, the end behavior is different, but everything else is pretty much the same. It has 5 terms. They have the exact same zeros. It's just how it finishes, and the picture is literally just flipped over. Sorry, my video froze there. So this and that are just, it's the same graph, just one's flipped. Okay, so that negative, all that did was flip it over and it changed the end behavior, but everything else is the same. So what I want to do now is I want to look at this guy here. So how we're going to fill this table out. We kind of know everything that's going on. And our goal for this, I can sketch the graph of a polynomial given in factored form using the degree, leading coefficient, and the x-intercepts. Okay, so these in general is just a sketch. It doesn't have to be picked. So the big thing here is we need to know the degree of the polynomial, whether it's even or odd, and whether the leading coefficient is positive or negative. That tells us the shape, the general shape of it. Again, not perfectly exactly the graph, but the general shape. So using your ideas from the warm-up that we just did, if you notice, there was an example. Let me flip back to mine. It was even with a positive. This was number 2. This was number 2 on our warm-up. And if this is the coordinate plane, as you go off to the right, it's going up. Now, the number, where it hits the x-axis and all the stuff going on in between, we don't know. But I know as I go to infinity, it's going to be going up. And as I go to negative infinity, it's going up. So it's going to be an up and up. That's how we'll describe it. If it was even and negative, do we have one of those? Let me look back at my... We did not have one that was even and negative, but all that does is if it's even and negative, as you go off to infinity, it goes down. It might do a whole bunch of turns and twists. We have no idea what's going on in between, but as you go to negative infinity, it's also going down. So this would be a, I didn't leave room to write it, this would be a down, down. So notice if it's even, they're going in the same direction. They're both up or both down. And the positive kind of tells you, positive's up, negative down. When it was odd, so this was the other 3 situations basically. So number 1 and number 3 on our warm-up, they were both odd and they had this shape where going to the right it was going up and going to the left it was going down. So it was a down, up situation. Okay, now when it was odd and negative, this is number 4. Number 4 is the other way. it was going up to the left, going to negative, going to negative infinity, it's going up, and going to the right, it was going to negative infinity, going down. So it was an up-down situation. So if I look for the degree, if it's odd or even, and for the leading coefficient, whether it's positive or negative, I can get the general shape of it. Okay, so given the sketches, the following sketches, what degree and leading coefficient sign do each of them have? Okay, so for this first one, they go in opposite directions. I should have said this too. Odd, we said even was same direction. Odd is opposite direction. Opposite direction. And if it's positive, think of it as positive slope going up and to the right. So it's going down and up. And if it's negative, it's kind of like negative slope going down and to the right. So it has this kind of shape. That's how I remember it anyway. So this guy here, it's opposites. Okay, so if it's opposites, it means it has an odd power. I can't tell you exactly what that number is, but I know it's odd. And it's positive, so it's kind of a positive leading coefficient. It kind of has a positive, it's increasing from left to right overall. Even though it has a little dip here, it's going down, going up. This one here, they're going the same direction, so that's even. They're both down, so it's negative. Okay. This one, same direction, even, but they're both up, so it's going to be positive. This guy here is going opposite directions, so that's odd. And if you think from left to right, eventually it's going to be going down. Okay, so it's going to have a negative slope, or think of it as negative slope, so it's got a negative leading coefficient. Now, let's take that a step further and throw in the zeros. So I'm going to get the end behavior and the zeros on this one and try to put it all together. If I were to multiply this together, it would be a positive x squared. So that means it's going to be going up to the right and up to the left. Now the actual zeros are at 2 and negative 1. So at negative 1 and at positive 2, it has zeros. So this shape is going to be something like this. Also note that the second power means two turns. Two directions. So down and then up. Now that's not a perfect shape or a perfect graph, but that's a general shape. This guy here, if I multiply these together, it'd be a positive x cubed. So that's odd. That means they're going to go in opposite directions. And since this is positive, think of it as going up and to the right. So it's going to be that kind of a situation. So going this way and going that way. And then the actual zeros are 0, 2, and negative 1. So plot those points. Negative 1, 0, and 2. Notice the multiplicity here. I should have mentioned that too. The multiplicity and all these are 1. So we're still going through the points. There's no touch and turns. It's going through. So it's going to go through, through, and through. Again, these both over here, multiplicity of 1, so it went through and through. Okay. Backside. If I multiply these together, notice there's a squared here. So that would result in an x squared. Another x would be x cubed. Another x would be x to the fourth. And it's positive. Okay. So even exponent means they're both going up. It means they're going the same direction. This means both up. So this is going to be going up and up. Now put in the actual zeros. The actual zeros are 0. Notice this is a squared, so this is going to be a 2, but that's going to be, you want to write this, you'd say a turn or a bounce. That one has a multiplicity of 2, so instead of going through at 2, it's actually going to touch and turn, and then negative 1. So at negative 1, 0, and at 2, but 2 is important. It's going to touch there, so it's going to touch. So if I come down, it's going to touch and turn back up. So instead of going through and going like this, it's going to touch and turn. This one is a through, so it's got to go through it and then back through it again. Okay, so it looks something like that. That's the general shape. Okay, this guy here, x squared, that would result in x squared, that would result in x. So it'd be a total of x to the fifth. Notice the negative out front would make that a negative. So the leading coefficient is negative, the exponent is odd. So odd direction, negative means it's going to be going like this. It's going to be going up and then going to be going down over here. That's the end behavior. Now the in-between behavior are these zeros. So x equals 0, 2, and negative 1. These have a multiplicity of 2, so these are touches. I'll just put a T under them for touch. Okay, so at 0 and at 2, I want to touch. At negative 1, I want to go through. So negative 1, 0, and 2. You can start from the left or from the right. It doesn't matter. Just got to follow these guidelines here. So if I start from the left, this -1 is a through. So I'm going to come down, go through it. At 0 is a touch. So I touch and turn. And this 2 is also a touch. So I touch and turn and come back down like that. So kind of weird looking, but that's just my general sketch right now. Okay. Number 5. If I were to, and you can pause at any time. Pause these and just try it yourself and see if you're, kind of quiz yourself. If you're feeling kind of stumped, you do need to try it yourself. Okay. So if I did multiply this all out, I'd have x to the third, and it'd be a negative. So odd means opposite direction. Negative means it's going to be going down to the right. So it'll be up this way, down that way. And then the zeros themselves, they all have a multiplicity of 1. So it's kind of one of the normal ones. We're just going to go through all these points. So at -5, 1, 2, 3, 4, 5, there's a 0. At 3, there's a 0. And at -1, there's a 0. And at all of these, I'm going to go through. So I might sketch this and go down here. So through, through, and through. And like that. If I multiply this together, again, might want to pause it and try it yourself, but if I multiply it together, it'd be x to the 4th, it'd be positive. Even means same direction, positive means both up, so both up. So my end behavior is going to be going up, and the actual zeros, they all have a multiplicity of 1. So this is the normal where it just goes through it. There's no touches here. So I'm going to go through it at 0, at -4, at +5, and at +2. Okay? So all these are through. So through, 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 and then through again, and going off to the right. Number 7, again, if you multiply it all together, notice one of these is negative, so it'd be a negative, but then I have x squared is, and then another x would be x to the 4th. So 4 means same direction, even means same direction, negative means they're both down. So this is going down both directions, down, down. And at 0, I have a 0, I have an x-intercept. Going to go through there. Now this 5, it's a square, so that means that 5 is going to be a touch and turn. So 1, 2, 3, 4, 5. And then at -2, it's a through. So I'm going to go through, through, and then this one I have to touch. So through, through, and then just touch and come back down. So it looks something like that. And these aren't perfect. Don't worry about how your shape looks. When we go to grade these, we're not going to worry about all that shape too much, but this guy here, it's going to be a big one. Okay, so I got x squared, x to the 3rd, that's 5, 6, and 7. So the x to the 7th, they're all positive. Okay, so 7 means it's going to be opposites. Positive means it's going to be looking like this, so up to the right, down to the left. Now the actual zeros, at -2, I've got a touch. At 1, that's a 3rd power. That's odd, which means it's actually just going to go through it. So don't have to worry about, a 3 is the same thing as a 1st power. It's going to behave the same. -4 and 3. So we got -2, -4, 1, and 3. And I just have to remember at -2, this is going to be a touch. So if I start either from the left or from the right, it's up to you. I'm going to go, this is a through, this one is a touch, and then a through and a through. Okay. Now if you're doing these touches wrong, like if I accidentally didn't touch here, I would have gone down, through, and through again, I'd be stuck. I was supposed to be going up and I'd be going down, so that's kind of a way of checking yourself. If it doesn't end the way you thought it was going to end, then you know you did something wrong. Check the multiplicity, make sure there's no touches in there or bounces. Maybe a B for bounce is better because touch and through both start with T, but I tried to put T's on the ones that are different and then nothing on the ones that go through. But yeah, be careful on this. So maybe use pencil for these too if you're trying to do it on paper, pencil paper. Don't use a pen like I did. Use a pencil, that way you can erase it.